Next is Cauchy's integral theorem. Very important. Cauchy's theorem is different and Cauchy's integral theorem is different. Cauchy's integral theorem is this one. They must state and prove Cauchy's integral theorem. Statement: if f of z is analytic within and on a simple closed curve C and A is a point within C, then f of A equals 1 by 2 pi I integration C f of z by z minus A into dz. Proof: draw the figure. You center point A and radius R, enclose it by a circle gamma, again the circle C. Since A is a point within C, we shall enclose it by a circle gamma. Z equals A as center and R as radius, such that gamma lies entirely within C. The function f of z by z minus A is analytic inside and on the boundary of the region between C and gamma. We have, this is property, integration C f of z by z minus A dz equals integration gamma f of z by z minus A dz. Both are same. This circle and this one. Call this as equation 1. Now put equation of circle. Put z minus A equals r e power I theta. Take this A to RHS. Z equals A plus r e power I theta. Now differentiate this. dz equals constant 0. Differentiation of this one, r write as it is. E power I theta differentiation is I into e power I theta d theta. And theta is, since this is a circle, theta varies from 0 to 2 pi. Equation 1 implies, substitute these in equation 1. LHS write as it is, integration C f of z by z minus a dz equals integration 0 to 2 pi. Theta varies from 0 to 2 pi. Here z means a plus r e power I theta, z minus a. Z minus a means r e power I theta, and dz means I r e power I theta d theta. R get cancel, e power I theta get cancel. I take outside, integration 0 to 2 pi f of a plus r e power I theta d theta. As r tends to 0, suppose if r is 0, I into integration 0 to 2 pi f of a into d theta. F of a into d theta. Integration of d theta is theta. Integration of d theta is theta over the limit 0 to 2 pi. Upper limit 2 pi minus lower limit is 0. That equals 2 pi I into f of a, or f of a equals 1 by 2 pi. If you take this to left side, it goes to denominator. 1 by 2 pi I integration C f of z by z minus a into dz. Hence the theorem. In problems you are going to use this formula. Okay, this also in problems you are going to use. This is generalized Cauchy's integral formula. F n of a equals n factorial by 2 pi I integration C f of z by z minus a whole power n plus 1 into dz. In denominator, if there is power means z minus a whole square, whole cube, like that means you have to use this one. Generalized Cauchy's integral formula.